This lesson covers the partial fraction decomposition of rational expressions with denominators containing repeated linear factors. We start with a note. If a denominator contains a linear factor repeated n times, the rational expression will decompose into rational expressions with denominators containing powers of the linear factor, the powers being 1, 2, 3, etc., up to the highest power of n. In this case, we have x squared plus 4x plus 6 over x plus 1 cubed. I need to allow for the possibility of this rational expression decomposing into rational expressions with denominators containing x plus 1 to the first power, x plus 1 to the second power, and x plus 1 to the third power. It is possible that in the decomposition process we will find that a equals 0 or b equals 0 or c equals 0. In this case, it does turn out that a is equal to 1, b is equal to 2, and c is equal to 3. We will work through the example of 5x squared plus 17x plus 26 over x plus 3 squared times x minus 1, and we will decompose this rational expression, starting with setting up the decomposition, substituting variables a, b, and c, etc. for missing numbers. So we set this rational expression up to be equal to a over x plus 3 plus b over x plus 3 squared plus c over x minus 1. I will then multiply both sides of this equation by the least common denominator, which in here is x plus 3 squared times x minus 1. We then have 5x squared plus 17x plus 26 equals a times x plus 3 times x minus 1 plus b times x minus 1 plus c times x plus 3 squared. Next, we solve for missing numbers. To start with, let's plug in 1 for x. I will then have 5 times 1 squared plus 17 times 1 plus 26 equals a times 1 plus 3 times 0 plus b times 0 plus c times 1 plus 3 squared. So simplified, we have 48 equals c times 16. Dividing through by 16, c is equal to 3. Okay, so we've solved for c. We move on then. We'll next let x be equal to negative 3. And if x equals negative 3, I have 5 times negative 3 squared plus 17 times negative 3 plus 26 equals a times 0 times negative 4 plus b times negative 4 plus c times 0 squared. Simplifying, 20 equals b times negative 4. Dividing through by negative 4, b will be equal to negative 5. Okay, so we have a left to solve for. At this point, there are no values of x that will zero out terms, so we will just choose any value we like. And so I'll let x be equal to 0. 0 is a nice number. And if I plug in 0 for x and also plug in the b value of negative 5 and the c value of 3, then we have 5 times 0 squared plus 17 times 0 plus 26 equals a times 3 plus times negative 1 plus b, which is negative 5, times 0 minus 1, which is negative 1, plus c, which is 3, times 0 plus 3, which is 3 squared. Simplifying, we get 26 equals a times negative 3 plus 5 plus 27. Simplifying further, negative 6 equals a times negative 3. Dividing through by negative 3, I find that a is equal to 2. Okay, so we found all three values for a, b, and c. We use these solutions for our variables to complete the partial fraction decomposition. So a equals 2, b equals negative 5, c equals 3. Remember, originally we set up 5x squared plus 17x plus 26 over x plus 3 squared times x minus 1 to be equal to a over x plus 3 plus b over x plus 3 squared plus c over x minus 1. So I have decomposed my rational expression into 2 over x plus 3, negative 5 over x plus 3 squared and 3 over x plus 1, or x minus 1. So my result is 2 over x plus 3 minus 5 over x plus 3 squared plus 3 over x minus 1. Try on your own. Find the partial fraction decomposition of 5 minus 3x over x minus 1 squared.